So now we move on to another section, right? So this is input and output devices. Now you need to be aware of laser printers first of all. So laser printers use dry powder ink rather than liquid ink and make use of the properties of static electricity to produce text and images. If you're a student from O-level physics, you'll probably be aware of this from a static electricity chapter, which tells you the usage of how a laser printer works. But still, since it is inside of our Cambridge syllabus, so we'll be going over how uh, laser printer prints a single page, right? So now another thing that you may be need to be aware of is color printers use four toner cartridges, which are blue, cyan, magenta, and black, right? Now you have a sequence of steps on how a laser printer prints a single page. So a laser beam and a rotating mirror are used to draw an image of the page on a photosensitive drum. So you have your page that you want to print, so an image of it is drawn on the photosensitive drum. So the image is converted on the drum into an electrostatic charge. So you change that into an electrostatic charge. Then the electrostatic charge attracts the toner being the liquid, the powdered ink. The charged paper is then rolled against the drum, and the oppositely charged paper picks up the toner particles from the drum. And after picking up the toner, the paper is discharged to stop it from clinging onto the drum, right? And then the paper passes through a fuser, which heats up the paper, and then the toner melts and forms a permanent image of the paper. The electrical charge is then removed from the drum and excess toner is collected, and then you get a printout of your print that of your page that you are printing, right? Now we move on to inkjet printers. So inkjet printers have a print head considering of nozzles that spray droplets of ink onto the paper to form characters, right? They have an ink cartridge or cartridges, either one cartridge for each color and a black cartridge, or a cartridge containing all colors and one for black. A stepper motor is also present with a belt that moves the printhead assembly across the page from side to side to print each character. It also contains a paper feed that automatically feeds the printer with the pages as they are required. So there are two technologies present for printers here. So you have thermal bubble and you have a piezoelectric printer. So let's go over the working of a thermal bubble. So these are tiny resistors that create heat, which makes the ink vaporize. This causes the ink to form a tiny bubble. As the bubble expands, some of the ink is ejected from the printhead onto the paper. When the bubble collapses, a small vacuum is created, which allows fresh ink to be drawn into the printhead. Whereas in piezoelectric, a crystal is located at the back of the ink reservoir for each nozzle. So you have all nozzles and a crystal is located behind those. The crystal is given a tiny electric charge which makes it vibrate. So you have this vibration, and this vibration forces the ink to be ejected onto the paper. So you're going to be vibrating that, and then the ink would be ejected from the nozzle that way, right? And onto the paper, and at the same time more ink is drawn in for further printing. So this vibration acts in a two-way handshake. So you force ink out while at the same time you get ink for the next page to be printed, right? So you need to be aware of the sequence of steps on how an inkjet printer works. So first of all, these four steps are common for the background steps for the printer process, right? So data from the document is sent to the printer driver. The printer driver ensures that the data is in a format that the chosen printer can understand. A check is made by the printer driver to ensure that the printer is available to print your paper, as you can't print, of course. The data is sent to the printer and stored in a temporary memory known as the printer buffer, right? So these are the specific steps for an inkjet printer. So we'll go over this. Then a sheet of paper is fed into the body of a printer. A sensor detects whether the paper is available in the paper feed tray. If it is out of paper, an error message is sent back. As the sheet of paper is fed through the printhead moves from side to side across the paper, printing text or image. So the printhead moves the nozzles across and they print the characters line by line, right? The four ink colors are sprayed in exact amounts to produce the desired final color that was present in the paper you were about to print, right? You gave the printing command. In the end, each full pass of the printhead, the printer is advanced very slightly to allow the next line to be printed, and this continues until the whole page is printed, right? And then there's another common step. If there's more data in the printer buffer, then the whole process from step 5, which is a sheet of paper is fed, is going to be repeated until you are done with all your printing papers, right? Then we have 3D printers. This is a new technology and it's very useful. It's very useful in real life. So they are used to produce working solid objects primarily based on inkjet and laser printers, and 3D printers use additive manufacturing, meaning that the object is built up layer by layer, or also there is subtractive manufacturing, meaning the removal of material to make the object. So there's two kinds to the 3D printing process. There's direct 3D printing, which uses inkjet technology, meaning a print head will be moved left to right as a normal printer, but the print head can also move up and down, basically giving you three-dimensional accuracy. So you'll be working with 3 dimensions. So your print head can move left and right, up and down in 3 dimensions, right? Then there's also binder 3D printing that's similar to direct 3D printing. There are two passes used for each layer. The first pass sprays dry powder, and then on the second pass, a type of glue is sprayed to form a solid layer. So now we move on to speakers, right? So I think everyone's been aware of how speakers work, right? You have a microphone, you have a speaker, or you generally have a speaker in your computer on your smartphone, right? So let's go over what a speaker is. So these are digitized sound stored in a file on a computer, can be converted into sound by. So you have digitalized sound. So digital sound that is stored in a file on a computer, and this can be converted. So the digital data is first passed through a digital to analog converter, right? So DAC, where it is converted into an electric current. This is then passed through an amplifier. Since the current generated by the DAC will be small, so you'll have to upscale it to create a current large enough to drive a loudspeaker. This electric current is then fed to a loudspeaker where it is converted into sound. Now you have some steps for how a loudspeaker works. So when an electric current flows through a coil of wire that is wrapped around an iron core, the iron core becomes a temporary electromagnet. So you use the electromagnetic induction process on how a loudspeaker works. A permanent magnet is also positioned very close to this electromagnet. As the electric current flows through the coil of wire, the coil of wire varies. The induced magnetic field in the iron core also varies, so they both vary. This causes the iron core to be attracted towards the permanent magnet, and as the current varies, this will cause the iron core to vibrate. So your iron core will start to vibrate. So you can look at this. This is your iron core, and this begins to vibrate, right? And since the iron core is attracted, or it is attached to the cone, so this iron core is attached to this cone, and this causes the cone to vibrate as well, producing a sound. And another point you may remember is that the rate at which the DAC can translate the digital output into analog voltages is known as the sampling rate. So now we move on to microphones. So we all be aware of microphones that are present inside of our phones. You have separate microphones, you have microphones in headphones. So we'll go over the basic functionality of how a microphone works. So when a diaphragm in the microphone picks up the air vibrations, the diaphragm also begins to vibrate. As we all know, the sound we produce is passed on due to air vibrations. So the diaphragm, so you can see the diaphragm, this will pick up your sound waves, right? So a copper wire is wrapped around a permanent magnet, and a coil is connected to the diaphragm using a cone. As the diaphragm vibrates, the cone moves in and out, causing the copper coil to move backwards and forwards. So your copper coil will move backwards and forwards. This forward and backward motion causes the magnetic field around the permanent magnet to be disturbed, which induces an electric current. The electric current in there is either amplified or directly sent to a recording device. So now we move on to screens. So there are I guess two types of screens in our syllabus. So first of all, we need to be aware of what OLEDs are. So OLEDs is the craze in recent years, and now you're moving on to newer technologies, but this is our limitation of the syllabus, so we'll go over OLED. So OLED is organic LEDs, as you may know. So the use of organic materials to create flexible semiconductors, that's why you see this helps for curved TVs, right? Helps for curved TVs. So organic films are sandwiched between two charged electrodes. When an electric field is applied to these electrodes, they give off light. So that is how you generate light. This means that no backlighting is required. So this is a very good saver. That is why OLEDs do not take up that much electricity, because they create their own backlighting. These also allow for very thin sheets. This technology also uses pixel matrix to make up the picture. And as you know, the greater number of pixels on the screen, the greater the screen resolution is. So now we move on to capacitive screens. So these are made of many layers of glass that act like a capacitor, creating electric fields between the glass plates in layers. So you have this, you have this. So then you'll have electric current here, right? And and when the top layer is touched, so when your top layer is touched, the coordinates where the screen are touched are determined by an onboard microprocessor. This is because the electric current changes when you press. So the benefits of this is that it is a medium cost technology. The screen visibility is even good in sunlight and permits multi-touch capability, and the screen is also very durable. Whereas the drawbacks to this is that only allows use of bare fingers as the form of input, although the latest ones may support a special stylus. So now we have resistive screens. So they make use of an upper layer of polyester and a bottom layer of glass. When the top layer is touched, the top layer and the bottom layer are joint and they complete a circuit. Then the signals are sent, which are interpreted by an onboard microprocessor, and the calculations are used to determine the coordinates of where your screen was touched. So the benefit of this is that it is relatively inexpensive as compared to capacitive, and it allows bare fingers, glove fingers, stylus to carry out any operation to touch. So the drawbacks to this is that the screen visibility is poor in strong sunlight, and the screen durability is not that good and does not permit multi-touch capability like the capacitive touchscreen does. So now we move on to virtual headsets. So you need to know how virtual headsets work. So the video is sent from a computer to the headset either using an HDMI cable or a smartphone that is fit inside an headset. You may see you have these you have these on your headsets, so you can attach your smartphone inside and then you can see the feed. The two feeds are sent to an LCD or OLED display. So you have this OLED display inside of your headset, and the two feed and there are two of these because one for each side of the image. So you have two eyes, so therefore two of these, right? Lenses are placed between eyes and the screen and allow for focusing and reshaping the content for each eye, giving it a 3D effect, right? A frame rate of 60 to 120 frames per second is used to give a true and realistic image. And as the user moves their head, a series of sensors are present, or even LEDs can be used to measure their movement, which allows the screen to react to the user's head movement to provide him with a real life experience. These headsets also use surround sound to give the user a 3D realistic sound, right? Now we move on to our most important topic, which is sensors. So sensors are input devices which read or measure physical properties, right? Computers cannot make sense of analog data. Computers only work on digital data, and this data needs to be converted into a digital format. So sensors measure in analog, but you need to provide the computer with a digital format. So hence they use an analog to digital converter to convert these physical values into discrete digital values, right? Then you have your monitoring and control system. So you need to be aware of how monitoring and controlling systems work. So the sensors send signals to the microprocessor or computer. The signals are converted to digital using analog to digital converter, since sensors measure in analog. The microprocessor or computer analyzes the data received by checking it against the stored value. So you have a preset defined value. So the data provided by sensor is checked against that. So now we'll split into it. So we'll be going over the left side first. So if the new data is outside the acceptable range, a warning message is sent to a screen or an alarm is activated. The microprocessor or computer has no effect on what is being monitored, right? So this is on the monitoring side of the system, right? So when you if the data is outside of the range, so you can only alarm the head of this whole process, right? Whereas if you move on to controlling system, if the new data is outside the acceptable range, the microprocessor or computer sends signal to control valves and motors. The output from the system affects the next set of inputs from the sensor. So these have preset defined. If a data is out of range, and then you have something like if temperature too high. So let's imagine temperature too high. So if the temperature is too high, so a controlling system can itself bring the temperature down to a preset value, whereas a monitoring system can only send alerts. It cannot take action itself, right? So now we have common sensors and their type. So do you have temperature sensor, and where is it used? So it is used in a central heating system. It also monitors temperature in a greenhouse. And you have moisture and humidity sensor. So they are also used in a greenhouse. Light sensors are used to switch lights on and off during day and night. Control lights in a greenhouse. Infrared motion used in detecting intruders inside in a burglar alarm system. They're also used to count people entering and leaving in the building, right? You have pressure sensor, and that is also part of your burglar alarm system. And you can also monitor a process where the pressure is important. Then you have gas sensors. These are used to monitor pollution levels in a river or air, or these are used to measure O2 and CO2 levels inside of a greenhouse. Then you have pH sensors, and these are used to monitor, control acidity, alkalinity levels in a soil, and monitor pollution levels in a river, right? So this is for the chapter of hardware, and this is all you need to know. This is basically a chapter which is full of memorization. I hope you may have understood what I had to offer. Thank you for watching.